In 5.6, we're going to tackle function operations. So the first operations that we're going to take a look at are adding and subtracting functions. So we're given let f of x equals 4x plus 7 and g of x equal the square root of x plus x. What are f plus g and f minus g? And then what are their domains? So if we're going to do f plus g of x, we're going to first write it out and state what the operation is that we're going to perform. Then what we're going to do is we're going to work left to right. So we're going to say we have f of x, so we're going to substitute in f of x. F of x is 4x plus 7. Then what's the next thing that we've got in our directions? We've got a plus sign. So we're going to put a plus sign directly after that quantity. Then the next thing that we've got is g of x. So right after that plus sign, we're going to write in the quantity that represents g of x. So the square root of x plus x. Now what we're going to do is order of operations. So we're going to look at each of the quantities and ask ourselves, is there anything that we can do to simplify inside the parentheses? In both cases, there's nothing that we can do to simplify inside the parentheses, so we drop the parentheses. We're left with 4x plus 7 plus the square root of x plus x. At this point, combine like terms. So the 4x and the x can be combined, so we get 5x, and then we've got the square root of x plus 7. There's nothing else that can be done, so that is going to be the solution. Now we've got to figure out what is the domain. So there are two things that we're really going to be looking at here. Do we have a radical sign? Do we have any fractions? And if we've got a radical sign or fractions, do we have a variable in the radicand, or do we have a variable in the denominator of the fraction? But we do have a square root with an x in the radicand. And since we've got an even indexed root, that means that we can't have a negative number for the radicand. And so what we would normally do is set the radicand equal to 0 and then find out what would make that equal to 0, and then it's going to be anything less than that number cannot be x. Well, in this case, if we set x equal to 0, we just get x equals 0. So we know that x can be 0, but it can't be anything less than 0. So the domain is going to be 0 to infinity. So in the second part of this problem, we're going to do f minus g of x. So again, just like we did on the last one, work left to right. So we start with f of x, which is 4x plus 7. Then we have a minus. Then we have a square root of x plus x, taking the place of g of x. Now, in the first part, 4x plus 7, there's nothing we can do, so we drop the parentheses. But for the second part, we've got a negative sitting out in front of the quantity. So we need to distribute the negative through. So that's going to leave us with negative square root of x minus x. Again, combine like terms. 4x minus x is 3x. Then we get negative square root of x plus 7. So that is going to be the solution. Again, we've got to look at the domain. We have a radical with x in the radicand, and so x cannot be less than 0, so the domain is 0 to infinity. In problem number 2, we're going to look at multiplying and dividing. So this time we've got f times g of x, with f of x equal to x squared minus 9, and g of x equal to x plus 3. So just like we did with addition and subtraction, we're going to work left to right, start with f of x. F of x is x squared minus 9, so we've got a quantity, and we're multiplying it against another quantity. So we get x squared minus 9 times x plus 3. Well, you've got a binomial times a binomial, so that tells us to FOIL. So we work that through, we get x cubed plus 3x squared minus 9x minus 27. This time we don't have any radicals, we don't have any fractions, so there are no restrictions on the domain, so we get a domain of negative infinity to infinity. The second part of this problem requires us to do f over g of x, or f divided by g of x. So start off with, in the numerator, we've got x squared minus 9, and in the denominator, we've got x plus 3. Now what we've got to do is go ahead and take that numerator and we want to go ahead and factor that. So since we've got a difference of squares, it's going to be x plus 3 times x minus 3. In the denominator, we've got an x plus 3. So the x plus 3 and the x plus 3 cancel out. You're left with just x minus 3. Now to figure out the domain, we've got to go back to the first fraction that we wrote, which is the x squared minus 9 over the x plus 3. Or you could look at the factored form before we did any canceling. We've got x plus 3 times x minus 3 over x plus 3. Our only concern is that denominator. We need the denominator to not be 0. So what's the only value of x that makes that denominator 0? It's going to be negative 3. So that means that the only restriction on our domain is x cannot be negative 3. Now in problem number 3, we're going to compose functions. This is going to be a little bit different than what we just did. Whenever we're working with addition, subtraction, multiplication, or division, we're always going to work left to right. And we're going to write everything out left to right. Now what you see is that we've got g of f of x. So whenever you see g of f of x, or that g circle f, or h circle g, or h circle f, or whatever it might be, what you want to do is you want to start with the letter that's closest to the position of x, or the letter that's closest to the number that represents x. So in this case, we've got f of x equals x minus 5 and g of x equals x squared. And it asks us, what are g of f of negative 3, or what is g of f of negative 3? So we start with g of f of negative 3. Then, since we're working right to left this time, we're going to start with f of x. So put g of f of negative 3 is equal to x minus 5. Now what we're going to do is anytime that we see x, we're going to replace x with negative 3. So g of f of negative 3 equals negative 3 minus 5, and that gives us negative 8. So now we've figured out what f of negative 3 is. Now we need to find out what g of f is. So we're going to go back to g of f of negative 3, but this time we're going to work with g. And we're going to replace, we're going to put g of x onto the right side of our equation, and that's x squared. Now what we're going to do is, instead of placing negative 3 in for x, we're going to place in negative 8 in for x, which was our solution to f of negative 3. So we get negative 8 squared. Negative 8 squared is 64. That is going to be the solution to g of f of negative 3. In problem number 4, we're going to look at this, we're going to look at a modified problem, and we're going to look at how does this affect word problems, or how can we use this to solve word problems. So we're given you have a coupon for $5 off of a pizza. You also get a 10% discount if you show your student ID. How much more would you pay for a $20 pizza if the cashier applies the coupon first? So whenever we're dealing with discounts, sometimes it's better to take one discount before another, or the second discount before the first. You might actually end up getting more money off by doing that. So what we're going to do is we're going to say that x is the cost of the pizza, and f of x represents the $5 coupon. So f of x is equal to the cost of the pizza minus $5, so x minus 5. G of x is going to be the 10% discount. So another way of saying a 10% discount is saying you're going to pay 90% of the original cost, or 0.9 times the original cost. So g of x is equal to 0.9x. And what we're going to do is we're going to do g of f, and we're going to try f of g. And we're going to see which one comes out to be the cheaper price. So if we do g of f of x, then we're going to do g of f of 20, because the original cost of the pizza is $20. So we're going to start with f of x. So f of x was x minus 5. So g of f of 20 equals x minus 5. Then we plug in 20 for x. 20 minus 5 is 15. And now we go, since we've figured out what f of 20 is, now we're going to figure out what g, basically what g of 15 is. So g of x was 0.9x, and we're going to substitute 15 in for x. So we get 0.9 times 15, which is 1350. Now, the next thing that we're going to do is we're going to try this in reverse order with f of g of 20. So g of x is 0.9x. We're going to substitute 20 in for x. So 0.9 times 20 is 18. Then we're going to do f of x, and we're going to substitute our solution for g of x in for x. So we get 18 minus 5, which is 13. So the first time we did it, we got $13.50. The second time we did it, we got $13. So that means that there's a 50-cent savings if you do the 10% discount first, followed by the $5 off.